In this video, we are going to be looking at databases as a trash can. And this will be a part of the Tech Powwow series, but I am going to actually add it as well to the SQL Basics because for some of you, you are reviewing SQL Basics, and this will be important to think about how to think about databases, I should say. And for others of you, you're reviewing database basics or SQL Basics, and you work with colleagues that typically approach everything from an object-oriented perspective and are definitely missing the smart approach to how to think about databases. So a couple of years ago, well, it's about a decade ago actually, now that I think about it, I was working with a guy who told me that the problem with object-oriented developers is they tend to approach databases as a trash can. And in thinking about just my experience in working with like performance problems and architecture and design, I realized that he is very right on the money. Like that is exactly how object-oriented programmers tend to view databases, is that it's just a trash can. So I have two images here. One, of course, is a trash can, and the other one is a file cabinet. If you think about a trash can, and let's say you're using a trash can to just store things, you just throw everything into the trash can, and then when you need it, you have to go dig through what you need, right? So let's suppose you have insurance information, tax information, etc., and I am going to have to explain the context because, granted, 80% of you are not American, but for instance, you might have different types of insurance. Your tax information might be by year. You might have different years of tax information. It might be a lot of documents. So you're going to have to dig through that trash can to find where it is that your information is, right? And so that's going to take a long time to do depending on what you need. It'd be nice if it was the most recent, maybe it's going to be on top. But the bottom line is if you're going to need, let's say, tax information from 10 years ago, it's going to take a while to dig through to get that information, especially if you're storing everything in that trash can. By contrast, if we have a file cabinet, we probably are going to put, like in one drawer, we're going to put our tax information. In another drawer, we might put our insurance, different forms of insurance. We're probably going to organize that different forms of insurance. Again, this is kind of an American context, I realize, but let's say we have homeowners insurance or auto insurance or health insurance. There may not be that in other countries, or maybe there's a combination of those, but different types of insurance, we might have it organized. We might have it organized by year as well. The idea is that we can quickly retrieve information in a file cabinet. Another thing as well, and this might be a little bit contextual, but sometimes you might get, let's say, and I'll pick on an example here in the US, you get car insurance information, let's say the price increases or just the price. And in that packet comes all this other advertising. So now they're advertising homeowners insurance and other types of insurance. More than likely, you're not going to want to keep that other information. You're not going to store that. You're going to shred that marketing information because you don't need it. So think about the database example of we're not necessarily going to take everything that the user gives us, right? We're not going to always take every single data point. We're going to filter it out. We're going to sanitize it, right? And in some cases, we may only care about, let's say, the price increase in that document, right? So we might have a form that we have independent which tracks the price each year and the year in our file cabinet. And we don't even keep the document that has a price increase. We just jot down that price increase and then we shred the price increase document and throw it away. The idea is we're very selective about what we're putting in our file cabinet because we don't have an infinite amount of space, so we're considering that. Now, the reason why I use these examples is because if you're approaching a database as a trash can, it's going to be very disorganized. You're going to have everything in there. When it comes to what data you have in there, you're going to have bad data values potentially. You're not going to have sanitized things. When you do reporting, you're going to have all kinds of performance problems. By contrast, if you think about the performance of a file cabinet versus a trash can, the file cabinet is going to perform a lot better. You're going to be able to get information a lot quicker. You're going to also know how to store information a lot faster. You're going to be able to put things where it needs to be. Well, not necessarily store information faster. Actually, a trash can, you would just throw it in there. Your inserts, if you would be a little bit more difficult with the file cabinet. Okay, so there is a popular object-oriented programming person on YouTube. I'm not going to say his name, even though some of you will know who I'm referring to. And while I would certainly recommend him if you want to learn object-oriented programming, I would not recommend his discussion about anything related to databases because he thinks, or he said this about 10 years ago, that databases were going to be irrelevant. Obviously, they're not. And one of his things is we'll just dump everything into memory. Okay, name 5 elements on the periodic table that make up memory. This isn't going to be a long-term solution, and I would expect this, of course, from people who know very little about hardware or the real world and everything about software. So I'm never surprised when I hear this from people, but of course, memory prices are up. People have been complaining about that for a while. Yes, because again, the elements on the periodic table that make up memory are also up as well if you look at it. And so that's just part of the reality, right? And there's not going to be, as you can store more information into memory, you're going to be able to store more information in general, right? And I'll be blunt, storing as much information as you can in memory isn't even that efficient because a lot of information isn't even accessed. Any of us who've worked in data environments where we archive data, where you have reports that literally pull from it once a year, it would be a complete waste of resources to put that into memory. I mean, a complete waste of resources. That is perfectly fine where you want to use disk, right? So I don't even agree with throwing everything, even if I could, into memory. It's just not a good use case. More than likely, your environment's spending a lot more money than you want to. Okay, it's not even a good approach to data. Also, I want to point out that there's still efficient ways in which you can store things in memory. Some of you have watched my data archiving series on this channel. If you haven't, I suggest you watch it. One of the topics I discuss is, do we want to derive data or do we want to store derived data? And that's something you have to consider with archiving data. And one of the things that I point out is, how often are you accessing that archived data? If you're not accessing it that often, it might be faster to just derive the data on the fly when you're pulling that data from the archived data. Well, the same with memory, right? If we are thinking about derived data, do we want to store that in memory, or do we just want to derive the data on the fly when we're pulling it from memory, right? So I don't agree with people who think if we dumped everything into memory, we wouldn't need DBAs. Just the opposite, because there's still efficient ways of storing things in memory, right? It's not going to go away anytime soon, and data engineers, database developers, and DBAs are still going to be around, regardless of what people think. And then, of course, just from my perspective, and again, it's because I have a lot of experience in this, there's just a lot of data you actually don't want to store in memory. It's just not actually the most efficient thing to do. There's a lot of data that are perfectly fine on disk. Organization is just not going to be irrelevant. I know everybody wishes it was, but this the thing about object-oriented developers. They like to do the lazy thing. That can be very beneficial in code sometimes, but it's not necessarily the best approach when it comes to data, right? So I use two examples here. You have a table storing body temperature, and it's a 5-point decimal. It allows 2 digits for decimal places. A living patient reports a temperature of 0 degrees, right? That's impossible. That's not a value that should ever go in the database. Unless you want to store bad data, that's an invalid data point. There was something wrong with the measurement tool there, right? That's not a possibility. Another example here, we're storing 3 different types of nulls, which our application layer then has to handle, converting each of these to the right format on reports. I've seen this, and I've also seen examples with varchars. I've seen examples with dates, different date formats, where the company is using these different date formats to compare dates. And there's no reason for the date formats to be different, but there has to be all this casting and converting of the dates to get them into a similar format to then compare, which is just absurd if you think about it. And then when we report to the clients or whatnot, it might be another format. Well, anyone who knows anything about, we'll just pick on SQL Server here, knows you can store all of the same type of dates in SQL Server very easily to do all of your comparisons. And then on reports, you can cast them or convert them to a different date format for your clients if that's what they want. Right? There's no need to have all these different date formats that you're then going to have to handle. But again, if you're just taking everything and just dumping into a database because you view it as a trash can and not an organizational structure, you do that. But the problem is it ends up costing you in terms of performance. And this is the point, right? So organization eliminates or reduces, number 1, inaccurate data. Number 2, wasteful time retrieving information or comparing information, running any analysis. And then 3, it eliminates or reduces the ease of archiving. I shouldn't say the ease, I should say the difficulty of archiving data. I should inverse that there. But basically, it makes archiving data a lot easier because when we are ready to archive data in the past, we have that data in a format which we can easily get. And we can think about, for instance, again, using, if we need to derive data, we can do that a lot faster than if we haven't thought about our organization. So organization is not going to be irrelevant. And this applies to memory as well as disk, right? There's a way to organize your data in memory to where it's a lot faster to get and a lot faster to use. Okay. And then thinking about sets of data versus objects. This is why a lot of object-oriented developers, not all, but a lot of them do struggle. They're thinking in terms of objects, not sets of data. Okay. Most data performance problems arise because developers are thinking about objects over sets, i.e. this value versus these data. Right? So think about an example of this, and I highlight this. We store information by sets because this impacts our architecture, our storage, our querying, our indexing, etc. Right? So if we know that when we store this set of information, we're going to be comparing it a lot with dates, then we want to think about using a universal date format internally. That doesn't mean when we report to clients, we don't change up that format, right? But internally, there's no reason to have all these clashing types. Same thing with nulls. Right? But there's no reason to have 3 different types of nulls. I shouldn't see a null, a space, and then just a blank value. There's no reason for that. We need to use uniform values, and that should be handled before those data ever get into the database and into the table, etc. Right? So just as a case in point of these first 2 points, let's think about if we had a table where we were going to be running aggregates on the full table. So basically anywhere from 95 to 100% of the table is going to be used on our aggregates, right? How is that going to affect our indexing if we're not using an in-memory table, right? We're not going to be using a B-tree index. That's not a very effective index. We're going to be using a cluster column store index when we're talking about SQL Server, right? What if we're querying, let's say, less than 1% of data out of that table? Well, B-tree index is going to be very useful. What if our main concern is concurrency? We're in an OLTP environment and we have concurrency problems. We might actually look into like in-memory tables. That might be a good use case of that, right? Do you see how when we think about the sets of data and what we're doing with those sets of data, how it answers a lot of our performance problems? This is exactly what data architects, DBAs are supposed to be doing. Right? So just the opposite of what you typically hear, these positions are irrelevant. They're very relevant. And if you're in environments, by the way, I have been in an environment which did not approach data architecture correct, and it resulted in an over $1 billion lawsuit. So, I mean, it's very cheap to hire a data architect compared to a $1 billion lawsuit, or a DBA compared to a $1 billion lawsuit. So again, there is an approach to storing data right, and there is a wrong approach, and that wrong approach can be very, very, very costly, right? So data don't exist for us to get in whatever we want in whatever form we want. That's the trash can approach. We'll just throw everything into a database and we'll figure it out later, right? And then we'll go get it when we need it. We store data based on how we're going to retrieve the data or how we're going to use the data. This is this file cabinet approach, right? So for those of you who work in the data field, and again, most of you are DBAs or database developers, data engineers, or working in the data field anyway, you more than likely know most of this. So this video is more for your object-oriented programming colleagues. You can share with them. But for those of you who are, let's say, watching the series and you're new to the SQL basics, this is a really good way of thinking about what you're doing on the back end. Think about sets of data. Think about keeping the right data from the beginning, right? There are exceptions. There might be companies that intentionally store bad data. There's nothing wrong with that. But if that's not what your company is doing, then you want to clean that data. You want to sanitize it before it gets in. You want to maintain it in a way that's very comparable internally. And then when you do the reporting, that's where you can alter the data that you need. And you want to also be thinking about what you're going to do with derived data, because all of this makes it much easier or harder to manage your data environment.